All right, guys, so today we are starting the day one notes in a new unit, 8B. Remember, we talked about we're going to try to squeeze in one more unit before you guys are out of here. That time's coming in real soon. We're on the final stretch, counting down the days, but we still got a little work to do. So we're going to start with day one notes here. Today we're going to be kind of going back to the work we did with factoring, and we learned how to factor polynomial equations. Now we're going to learn how to solve for some of them. Okay, so today we're going to use the zero product property to solve for polynomial equations. You'll notice that in this box that we have here, there's actually four boxes, okay? Really, today we're just going to be going through one. That first one is the factoring method, okay? Before we get into that, you guys have a warm-up. This is going to take you back to your pre-algebra days. It's going to take you back to factoring a little bit for that last one, at least. And we'll see if you guys can get to that last one. I'm not going to do those. I want you guys to pause this video, try them on your own. That's going to be your warm-up into today's notes. Okay? So, zero product property. What is that all about? Okay? Well, notice that this equation that we have right here, you know what? I'm going to go ahead and use a different color. This equation that we have right here, same one we have over here, okay? What did we start out by doing when we were starting with that warm-up problem? Hopefully, you guys remembered that the goal when we have that type of polynomial is we need to find out what sums to 7 and multiplies to 10. What are those two numbers? What are the two numbers that's going to sum to 7 and multiply to 10? Hopefully you guys are screaming at the screen right now, and you know that the answer is x plus 5 and x plus 2. Okay? Now the difference in what we've done so far is that we now have this part in here that says equal to 0. Okay? So what is the zero product property? Well, that is us making these equal to 0. So in other words, x plus 5, that's going to equal 0, and so does x plus 2. That also equals 0. If I were to give you these two different problems, I think you guys would be able to tell me that I'm just going to subtract 5 here, and I'll get x equals negative 5, or I'm going to subtract 2 here, and I'll get x equals negative 2. Okay? For what we're doing today, that right there, that's our final answer. That's it. The zero product property is the step that we took in making each of these factors, this one right here, all right, that first binomial of x plus 5 and the second binomial of x plus 2, by making those equal to 0, that is the zero product property. I'm going to abbreviate that with ZPP, okay? So that right there is the zero product property, making those two binomials and setting them equal to 0. So for that question, both negative 5 and negative 2 are going to be your answers. X equals negative 5 and x equals negative 2. Okay? Let's move forward with that. So zero product property, I just showed you what it's going to look like. What exactly does it mean? Okay? So what it means is, let A and B be real numbers. If A times B equals 0, then A equals 0 or B equals 0. Okay? This property can be used to solve any polynomial equation when one side of the equation equals 0 and the other side is a product of polynomial factors. Right? A product of polynomial factors, that just means multiplying two polynomials. We did that here in our first example. We had two binomials of x plus 5 and x plus 2. Those were being multiplied to equal one side that equals 0. So we could apply the zero product property to that. Let's see if we can do it to all these other ones. Okay, what about this first one? I have x times x minus 1. Now remember, it says the property can be used when we have two polynomials being multiplied by each other. Remember, just because this is a standalone variable, just x, still a polynomial, so we can still apply this method. But what does it mean, okay? Well, it means we're going to have one expression that says x minus 1 equals 0. That's this one right here, okay? The other one, we're just going to take this x, bring it down. That just means x equals 0. That just means there's no algebra steps we need to do for it. Those are two polynomials being multiplied together, so the zero product property can be applied. Now, what this factored out equation originally looked like, remember if I'm just going to distribute this, now this is just to kind of show you guys where these numbers came from. That means that we started out with an equation that looked something like x squared, looked exactly like, I should say, x squared minus x. That's it right there. Now if we were to factor out this equation, we take out that x, that's what this final step entailed. So we ended up with a new expression of x times x minus 1. I should say that this is set equal to 0. That's why we can apply the zero product property. Okay? How about letter B? What's going on with letter B? Okay, so I'm just going to distribute this here and here to see what exactly the equation started out as. So 2x times 6x, that's going to be 12x squared. Remember, multiply the coefficients, add the exponents. And then I have a negative 10x. So that's what my equation originally looked like. Remember, I'm going to add in that equals 0 because we have that here this time. We're not used to seeing that, so that's important to pay attention to. Okay? All right. So if I were to factor out that equation, I end up with 2x times the binomial 6x minus 5. Well, this is going to be the same thing we had with that letter A, except it's just going to be a 2x that equals 0 as opposed to x. Now, I will have a step here that I have to do, but remember, I have 0 divided by anything. That's always going to be equal to 0, so x is still 0 for that one. The other equation that I'm going to have, and I'm going to zoom in so I go a little smaller here, is going to be 6x minus 5 equaling 0. Now I'm going to have a little bit, one or two more steps that I'll have to do algebraically. So I'm going to add 5 here, isolate that variable to one side, so I've got 6x equaling a positive 5. And now I want to isolate that variable even more, so I'm going to divide by 6, so I'll get x equals 5/6. Okay? So remember, x equals 0, x equals 5/6. Those are both your answers for this problem. Okay? How about this last one? C. I've got a negative times the binomial x minus 1 and the binomial multiplied by the binomial 3x minus 4. Okay? Here's what I want you guys to do. This number, this right here, this negative sign, that is the greatest common factor of this problem. That is a negative 1 that they took out, and that is in front of both of those binomials. It is the greatest common factor. Right now, what we're going to do, ignore it. Ignore that negative sign. The reason why we're going to ignore it is because we have these two polynomials being multiplied by each other, and the other side is equal to 0. So now we can still set those binomials equal to 0 and solve for x. So I'll have x minus 1 equals 0 and 3x minus 4 equals 0. X is still going to equal 1. 3x equaling, I got to add 4 to this one. So I've got 3x equals 4. Divide by 3. So I've got x equals 1 and x equals 4/3. Those are the answers. Now keep in mind, that negative sign had nothing to do with how we found those answers, right? Because there was two binomials already created, right here and right here, that were being multiplied by each other, equaling 0. So if that negative sign is out in front, that GCF, ignore it. We just need to find out what those x is by applying the zero product property. Okay, so the next step is to solve each polynomial equation by factoring. I got to go to the next page for this one. Okay, so Remember, in order to use the zero product property, and you know what, I'm going to go ahead and highlight this one because this is very, very, very important. Okay? In order to use the zero product property, the equation must be set equal to 0. Okay? Must be set equal to 0. So I'm going to go ahead and highlight that. I guess that didn't really work out too well, did it? We'll go over it again. 0. That'll do. Zero product property must be set equal to 0. Right? There's your key words, okay? So what we're going to do is we're going to look through these letters. We're going to use the space in the bottom to solve for them. And then we'll take a look at what our answers are, okay? But first I want to look at two specific ones. If we're supposed to be using the zero product property and the equation has to be set equal to 0, right away I'm going to notice that this one, letter E and letter D, both are not set equal to 0. Right? So what does that mean? Does that mean I just can't do it? Does that mean I just can't do anything? No, not necessarily. All it means is that we got to do a little algebra work to make it so it's set equal to 0. So let's do it with E. All right? E, I've got x squared minus 5x equals x minus 8. I can get it to one of these sides equals 0. All I'm going to do is I'm going to subtract x on this side minus x. So now my new equation is going to be x squared minus 6x equals negative 8. So now I'm just going to add that 8. Add 8. Remember, 8 is not like any of these other terms, so I can't combine that anywhere. So it's just going to be a trinomial expression of x squared minus 6x plus 8. Now it's going to be set equal to 0. Here's where I can use the zero product property, right? I can use the ZPP now. Okay? So now I'm just going to factor this expression. So what sums to negative 6 multiplies to 8? Hopefully you guys realize it's going to be x minus 2 and x minus 4. I'm just going to set both of these equal to 0, equals 0. X minus 4 equals 0. So my answer is going to be x equals 2 and 4. Where did I get those numbers? I'm going to add 2 to each side here. I'm going to add 4 there. So I'll have x equals 4 and x equals 2. I'll make it a little clearer for you guys so you guys really see where I got that from. So now I'm going to have x equals, x equals 2, x equals 4. All right? So there you go. I just did letter E. Can still figure out how to do it even if it's not set to equal or set equal to 0 right away. We just need to make it so it's set equal to 0. All right? What's next? The other one was letter D. What does letter D look like? Okay? I'm going to do that one right here. Letter D. I've got x squared minus 3x equals 4. I just need to make one of these sides equal to 0. This looks like the easiest side to do that. So I'm going to subtract 4. I'm going to have x squared minus 3x minus 4 equals 0. So now what sums to negative 3 multiplies to negative 4? Hopefully you guys realize it is x minus 4x plus 1. Both of those are equal to 0. I set x minus 4 equal to 0. I get x equals 4 by adding 4 to each side to cancel out that negative 4 on the left side. The other one is going to be x plus 1 equals 0. Subtract that 1. We get x equals negative 1. Okay? It is important to know that because all of these equations are quadratic, they're raised to the second power, right? All quadratics are going to have 2 solutions, okay? So I'm just going to make a little note of that actually right underneath this one that we did. I'm just going to put in red. Quadratics always have 2 solutions. I spell that right? Yes. All right. Quadratics always have two solutions. Okay? So there's a lot of other ones here. Let's see if we can get to work on all the other ones. Let's go with letter A. All right, so letter A. Zoom in a little bit here. A. That one is x squared minus 3x equals 0. All right? Well, here's the thing. This is not two polynomials being multiplied by each other. I can make it that by factoring out the GCF. So what I'm going to do is I'm going to factor out the GCF, which in this case would be an x. So I'm going to have an x times x minus 3. Now we've got two polynomials being multiplied by each other. So I'm going to have x equaling 0. There's one of my solutions. X minus 3 equals 0. That x minus 3 coming from here. Those are my two polynomials right there. Add 3 to both sides on this one to cancel out that constant, and I get x equals 3 and x equals 0. This was a quadratic. I had two solutions, so we're good. How about letter B? Let's move on to letter B. Zoom in a little bit because I know I'm running out of room. B. That one is x squared minus 3x plus 2 equals 0. This one's got to be factored as well. So now I'm looking for what sums to negative 3, multiplies to positive 2. Probably going to be x minus, not 3, x minus 2, x minus 1. That's going to add to negative 3. And that's going to multiply to a positive 2. Still need to bring down that equals 0, right? I've got two polynomials being multiplied together equaling 0. I can use the ZPP, the zero product property, to have x minus 2 equaling 0 and x minus 1 equaling 0. Add 2. There's one of mine, x equals 2. I'm going to add 1. Add 1. I get x equals a positive 1. So my solutions are x equals 2, x equals 1. If you want to also write this, you can also write this as a combination, so like x equals 1, comma 2. Or if you wanted to make it 2, comma 1, depending on whatever order you made that. That's fine too. I like to do it with just two separate boxes. Either way is fine, just as long as we know that x has two solutions and they are whatever we choose. Actually, I'll leave that in there so you guys can see. X equals 2, comma 1. Okay? All right, so let's do letter C. What does letter C look like? Okay, so letter C is going to be, we'll do it right down here, C. That is negative x squared plus x plus 42. Well, first things first, you guys probably noticed we have that negative sign in there. So let's factor out that negative. If I factor out the negative, then I'll be left with x squared minus x minus 42. If I do that, factor that expression, I'll end up with x minus 7, x plus 6. Remember, this is all equal to 0. I'm sorry, I forgot to bring that down. That's all equal to 0. If you remember from the example that we did earlier, I want you guys to take this negative sign, ignore it. We've got these two polynomials that are set equal to 0. We're just going to take those, leave them equal to 0. Plus 6 equals 0. X equals, we're going to add 7, so x equals 7. And then I'm going to subtract 6. To get x equals negative 6. Okay, so remember, if we factor out that negative, we have the negative in front. Ignore that for when you're using the zero product property. Okay, so what we've done so far is we did A, we did B, we did C, we did D and E. All that's left is F, I believe. 1, 2, 3, 4, 5, 6. Yes. So I want you guys to try f on your own. That's going to be good practice for you. I'll give you a hint. It's not going to be a pretty number when you get it. It's going to be a rational number, but not a whole number, not an integer, I should say. So give that one a shot. Remember to, you might have to go back and use some of your diamond math and A times C, splitting the B value kind of thing. It's going to be a challenge, but I want you guys to try it. This is the first part of the notes that we're going to do in terms of using the zero product property. We'll do even more of that starting tomorrow. But for now, give this a shot. Email with any questions. And as always, we'll talk to you later on.